everyone, welcome to the Nanodcal tutorials. In this tutorial, we will see how we can analyze current voltage curve. Before we start off the tutorial, I want to introduce myself. I am Sahil Verma, application engineer of the well-known company Impulse Technology. Number of the users asking about how we can analyze current voltage curve. So in this tutorial, we will be discussing about how we can analyze IV curve. Before we start off the IV curve analysis part, I'm going to show some small PPT and also want to tell about the Nanocadmic technology. It is a parent company which develops several softwares like Nanodecals, Rescue and KittyCats. In here we will discuss about the Nanodecals and about the Nanocadmic technology, what they are actually doing in here, like electronic properties of nanostructure and nanodevice, design, fabrications and test of high-performance nanosensors, advanced materials and nanotechnology for post-lithium-ion battery, metal alloy crystal in general with study of impurities, dopant and lattice mismatch, creation of novel functional materials, 1D, 2D and 3D nanomaterials engineering, next generation semiconductors, solar cells, membrane, photocatalysts, functional organic and inorganic chemistry, molecular design and simulations, interface between the solid or liquid compounds, microscopy like means electronic or advanced high resolution molecular spectroscopy, qubit modeling in semiconductor for quantum computers and telecommunications that have the separate software QTCAT. It is about the nanocadmic technology and their softwares, that type of properties and that type of functions we can analysis in this nanodecals and rescue and KittyCAT software. Basically nanodecals used for the material and device simulations parts, and rescue it is used for the material simulation, and KittyCAT used for the spin qubit material simulation. In the atomistics levels you can see nanodecals and rescue software. In here MATLAB plus C versions that have supported, and some of the analysis that you can done in these softwares: photocurrent, thermal transports, phonon tools, complex band structures, multiprobe transports, bend device current, IV curve and scattering states. At the different side, rescue, real space, hybrid functionals, BS or DOS, DFPT, phonon, IR, Raman spectrum, GPU expressions and dielectric tensors. In our previous video, you have already seen about the different properties and their analysis, how we can simulate, and in this video we will be only discuss about the IV curve. Now I'm going to open Device Studio. You can see in here the create a new projects and open existing projects. So we need to move at the create a new projects and click on the OK. Give in here the new names, like we can provide IV curve. It is new names. It is a Device Studio. About the Device Studio we have already discussed in our previous video. You can check out the playlist. At the brief section that you can see new projects, open projects, save projects, new, imports. So different tabs are given, and in the build tab you can see molecules, molecule 2D, device and interface builder, field junction with atoms, cat to atomics. Different tabs are available in here, like graphene nano ribbons, graphene nanotubes, disorder graphene like, and in here you can simulate nanodecals, nano rescue. After the nanodecal you can see when you select or import some of the materials and then tap the will automatics active. First we need to create one of the device structure, then after we can calculate IV curve. So move toward the file tab and you can see device, crystal and molecules. If you want to create in here the new device structures, you can move toward with this crystals, you can move toward this, and molecules ports one of the materials. So click on this and you can see that type of formats have supported. So you can also import online directly Google or Chrome. In the Device Studio some of the materials files already available on this. Click on this PC where your Device Studio presents. Number of the materials are available in here: 0D material, 1D material, 2D material, 3D material, organic material. When you click on this you can see amorphous and crystalline. Same for the 1D materials, nanotubes, 2D material, novelty materials and graphene, and 3D materials, conductors. Whole of the conductor files are available. Insulator, layer materials, magnetic material, metal oxide and semiconductor, and organic materials, crystal and molecules. We need to import one of the materials, like at the simple silicon you can import, and you can see that file have supported, and click on the open. Silicons semiconductor file have imported in here. When you click on this you can see their properties. If you want to redefine that crystals, you can move. In here you can create one of the supercell type like this, but we are going to create in here that simple device. Click on the file and you can see new and device. Like we are going to create that type of left, center and right type of device structures. You can see number of the device you can create it in here at that type form. Click on that LCR structure and OK. For the left electrodes, you can choose the pulse silicons. For the central silicon, it totally depends on the users which type of device they want to create. I'm just considering one of the simple examples and click on the match. And after that match, you need to click on that preview like this. You can see in here that left electrode and their surface vectors. If you click on this, you can also see their structures after the preview, and then you can build. So same match, and you can see in here the mismatch is 0.0, so you can click and then move toward the build like this. You can see that type of device, but you need to create in here that bond. You can see that tab are automatically active in here, like it is a arrow rotations, and for the XY, XZ and YZ and YX and ZX view, 3D viewer fit to view in here, that's display styles, structure refining modules. If you want to add in here the new atom, so you can add. Whole periodic table are available in here. If you want to delete some of atoms, replace of the atoms, so you can replace from here, but we need to create in here that bond, so you need to select this and click on the move atoms. We only want to move with the screen view, so you can use and give in here the distance value, so according to that value they will move like this. You can click and that bond have created in here. And now you can select whole of that silicon atoms and click on the center. It is your only device dot HZW files. You need to give in here that left electrode and right electrode value, like you can see, and it is editables. If you want to change, you can change. Click on the preview and then you can click on the build. So that type of device have created. If you want to create in here that buffer and want to increase the central regions, you can increase like this. So it totally depends on you if you want to increase in here the central regions, or if you want to reduce in here that value like this. So it totally depends on you. You can choose that type of value. User can also create your own device structures like this. Now you can move toward the simulator tab, Nanodcals and self-constituted field calculations. You can provide in here the basic settings, counter integrals, electrode, iteration controls. So you can see electron temperature, you can change, and energy cutoffs, you can see Rydberg and electron volts. Change correlations you want, you can consider k point samplings, and counter integrals you can see circle points, real axis point density and real axis infinite. You can see in here the electrode, left electrode and right electrode with the temperature, like apply voltage equal to VL minus VR. If VL is grounded, like VL equal to 0, and then you can apply plus 1 voltage, so you can give in here that 1 voltage. VL minus VR, that means 0 minus and minus 1 equal to 1 volts. So like this, if VR is grounded, so VL can be considered 1 and then apply voltage will be 1. Like if you click in here the 0.5 and in here you can give 0.5 minus, so VL minus VR, so that means it is a 1 volt. So but first we need to consider for only 0 biasing voltage and 0 apply voltage, then one by one you can increase in here your voltage. Iteration control, you can see density matrix, Hamiltonian matrix, and if you want to introduce total energy, you can give maximum steps, mix method, mix rates, Hamiltonian matrix, and density matrix, real space density matrix you can choose. Totally depend on the user. By elements or by atom, how are you terms for the transition element calculations. And if you want to consider doping, so you can use that tabs. Same for the spin, collinear spins, general spins. For the magnetic properties, you can move toward this collinear or general spins. We are considering either no spin because for the spin it take too much times, and after this you can click on the generate files. Now you can check in here that accept input files, what quantities should be calculated in here. You can see basic settings, description of electrodes, counter integrals, and central cell vectors and iteration controls and basic set. It is totally editable, so if you want to edit, you can edit and you can save from that tab. Same as you can see for the left, their scripts, and same for the right, their scripts. We are going to analysis in here the IV curve, so we need to move again simulators, nanodecals and analysis. And you can see left electrode. First we need to calculate in here that charge for the atom, and then click on the generate files, like choose left electrode and projected atoms and click the generate files. Click accept.input files and run files, because for the device first you need to run left electrode and then right electrode and after that device. For the nanodical sum files, nanodicals. When you click on the run button, you can see XCF field calculations have been started, and you can see V1, V2, V3. This is the central cell base vector V1, V2, V3 calculation of the rigid atomic fields. When it is running, after the XCF.input files, when it's completed, now you can see XCF.input field calculation have been finished. After this, you can run chart.input files. You can see the chart.input field calculation have been finished, and you can see that files chart.xml files. Then you can move toward the again simulator, nanodecals, analysis, and click on the right electrode and click on the charge atom. You can see near the momentums atom on orbitals. Click on that atoms and generate files. Click on the right sides and click on the run button. Exit.input files of the right electrode calculation has been started. That calculation has been started, and for the loop hash it is taken less time because we have considered only 6 number of atoms, like this you can see. But if you increases the number of atoms, so calculations time automatically increases. I'm just considering simple examples. You can take any type of device and then the same process you can apply to calculate IV curve. You can see the calculation for the XCF input right electrode has been finished. Now you can click on the charge.input files and click on the run. You can see that running condition calculation for the chart.xml files have been finished. You can see that the chart.input file. Now you can run that device except.input files after the left electrodes and their charge input files, and right electrode their charge input files. You can see the other running status. Again move toward the simulator and analysis parts. You can see the transmission. Generally transmission means the probability of the electron with a certain energy can pass through the device one electrode to the another electrode. Basically we assume for the IV curve it is not mandatory to calculate the transmission. You can analyze various type of properties like density of state, effective potentials and total energy scattering states. And in the nanodecals, current generally integrate with the each of the transmission, so you can also calculate the transmission and click on the generate files. Click on the transmission, open with. You can give in here that 100 value because calculations for the transmissions for k space grid number should be 100 as per the tutorial, and then click on the save button and then click on the run. Move toward the simulators, nanodecals and XCF calculations. You can give in here that 00 voltage as the scenes. Click on the generate files and then click on the run. The calculation has been started. With the Q form you can see is just for that IV curve after the transmissions you can see, but it for the only 0 biasing voltage. But if you want to move 1 volt 2 volts, again move toward the simulator, nanodecals and IV curve electrode, and you can give in here that 0.5 voltage minus 0. That means VL minus VR. It means equal to the 1 volt, and click on the generate files. You can see bottom sides and open with save.input files for the 1 volts had been generated. Click on that accept.input files and run. Same IV for and click on the run button. Again move toward the simulator, nanodecals, IV curve, and if you want to move much calculation for the 2 volts like this, click on the generate files. Totally depend on the users which type of electrode value they want to consider, they can choose, and again click on the run button. Again move towards the simulator, nanodecals, IV curve, and they can increase 1.5 and minus 1.5. Click on the generate file and click on the run button. and click on the run button. Whole calculation has been Q-formed. So it is the way to calculate IV curve for 0, 1, 2, 3 type of voltage. It will take too much time in here. Therefore, we have already simulated that type of projects. Right size and device studio. Open existing projects. Like you can see, same silicon we have imported and this type of device structures we have created, and now you can see left electrode and right electrode as the same, and the charge input files with the 0 voltage, 0.5, 1 volt, 2 volt and 3 volts. So in here you can see all the files have been calculated in here. Now you can plot each IV curve on the MATLAB, because IV curve we can plot in MATLAB. So open the MATLAB tab. Here your device projects have been saved. So select your project and now you can see that have been imported. Current voltage curve. When you click on this data, you can see it for the 0 biasing voltage. When you move toward that for the this voltage, you can see for the V1 0.5 that's current are available. You can collect one by one each data for the same again data, and you can collect these data again, load that current voltage mat files, double click and then collect these data. Now you can create that script. Click on this and click create in here your script for the voltage and current curve. And this type of script you can create like voltage V1 0, and for the 0 you can see 0, and for the 0.5 you can see for the 0.5 3.9 we have imported in here, and same at place you can see minus 0.5 that current we have placed. If you move downsides 1.5 like 1.5 and minus 1.5, you can see 1.5 that current have been imported in here, and minus 1.5 that current had been imported in here. Same for the 1, you can see 1 that current we have imported in here and that current we have imported in here. So this type of script you can create for the current and voltage curve. You can collect your data and then create this type of script and click on the run button. The graph has been plotted in here. You can see for the forward or reverse biasing voltage and the same type of graphs you can see it is created in here. So it process you can apply it and you can plot IV curve. Now I'm going to end in here my tutorial for the current voltage curve. You can follow that type of process and you can plot any type of device IV curve. Who has not seen it previous video, you can check out the playlist, and if anybody have query related to this, please ask in comment box, and my email are also available at the end of video and the description box. And who want to book our demo, please book in the Impulse Technology website. Thank you very much.